Okay, so the start of our Unit 2 packet, we're on page 1 in our new Unit 2 packet, and we're talking about this star problem that we saw at the beginning of Unit 1, and then this bagel problem, which is new to us. So I want to start with the star problem. What's the pattern here? How am I changing each time? I'm adding 1 to each sort of corner for a total of 2 stars added to each step. How many stars would I expect there to be in step 43? 87. How did you get 87? Okay, so you said we add 2 new stars every step. So after 43 steps, I'm going to add 2 stars for every step. And then you said I started with 1. Okay, so to make sure this works, I want to double check it with a couple of our others. So this would be 2 times, this is our first step plus 1. 2 times 1 is 2, plus 1 would give us 3. That looks good. If I check it here, 2 times, this is our second step plus 1. That would be 4 plus 1, which is 5. And that's what I have here. That looks good. Yeah, so what you did was essentially try to write like a rule or a little expression that could give me that total number of stars by plugging in the step I wanted, and then it would sort of give me that number of stars for that step, right? Okay. Did anybody start making a list of numbers? For like step 3, we've got 1, 2, 3, 4, 5, 6, 7. So for step 3, I've got 7 stars. So for step 4, add 2, I'd have 9. For step 5, I'd have 11. For step 6, I'd have 13. Did anybody start doing this? So you said I got to add 2 each time. So if I make a table, I'll get there, right? So did you get to step 43? Why not? Yeah, because you have to write a really long list to get to 43, right? I'm at step 6. Okay, so you can make a table and add 2 each time, since we know that's how this pattern progresses, but that's going to take a while. What we want is something that can get us that result a little bit faster, which would be a rule or an expression to be able to get there. Okay, so that's kind of one of the big things that we're going to focus on in this unit. We're going to be talking about functions, and so we'll talk about what it means to be a function here in just a minute. But this is what we like to have, some sort of rule or concise description for this pattern that I have. Now let's talk about our second problem. So the customer at a bagel shop is buying 13 bagels. The shopkeeper says that would be $16.25. Sarah, Alex, and Ryan, who are in the shop, all think this is a mistake. Sarah thinks the total should be $13.25. Alex thinks it should be $13, and Ryan thinks the total should be $11.25. So 4 different people have come up with 4 different totals for the same amount of product, for the same amount of bagels. Why is that? Yeah, our price here per bagel is not constant. So they give us a little bit of a discount as we buy more bagels. If I were to buy 6 bagels at $1.25 a piece, if I do that math really quickly, I would expect 6 bagels to cost me $7.50. But they're saying, hey, if you buy 6 bagels, you can only pay $6. So what we're seeing here, these different totals, are a result of finding our bagel total a different way, finding different ways to get to 13. So we had $11.25 as a total, $13, $13.25, and $16.25. How did they come up with a total of $11.25? $11.25. Yeah, so they got to 13 by doing 12 bagels plus one bagel. 12 bagels is $10. One bagel is $1.25. And that's how they got their total of $11.25. How about that total of $13? How'd they come up with that? Hattie, go ahead. So they did 9 bagels and then they did 4 individual bagels. 9 bagels is $8. And then this would be 4 times $1.25 to give us our total of $13. Good. How about that $13.25 total? Go ahead. Mm-hmm. 2 half dozens and then a single. So 6 bagels is $6, and then 1 bagel is $1.25. That would give me $13.25. And then how about the $16.25? Go ahead. 13 single bagels, right? So that's 13 times $1.25 would get me $16.25. Interesting that the store clerk came up with the most expensive total, right? Has anybody ever been to a restaurant or you've like ordered food and they're like, actually it's a little bit cheaper if you ordered this with like some modification? Has anybody ever had that experience? That's terrific, right? Because your cashier, your waitress, or whoever maybe saves you a couple bucks on whatever you were going to order. You get the same thing, but for a little bit of a maybe less price than if they had punched it in the cash register exactly the way that you ordered it. So what we're seeing here is kind of a variation on that. If I order the same amount of bagels, depending on how they punch it in the register, I could pay a bunch of different amounts from $11.25 up to $16.25, right? And this isn't even all the options. There are different ways that they could also type in 13 bagels. We could do 6 bagels and then a bunch of individual bagels, 7 individual bagels, and that would give us a new total even. So what we don't want when we talk about functions are situations like this, where I'm looking at one amount of bagels and I've got a bunch of different costs that could be associated with that. When I talk about functions, what I want is stuff like this. For a given step in my problem, I know it's going to be this many stars. So at the top of page 2, that's what they're going to ask us. Which of these are functions and which of them are not? So problem number 1 is a function. Okay. What I want from a function is that as I talk about a step in this problem, like with my star problem, I know exactly how many stars will be in that step. That's a function. That number is never going to change. That number of stars will always be the same if I'm talking about the same step in my problem. So intro problem 1, does it represent a function? Yes. Because each step of the problem will have a unique number of stars. It's this idea here that for each input, I have one output. Each step in my problem has a one set amount of stars. Each picture in that pattern is going to have a specific number of stars, and that number of stars is not going to vary. So step 13 will always have this amount of stars. Problem number 2 is not a function because we had several different possible prices for the same amount of bagels. Because there were several different possible prices for 13 bagels. The amount I pay for 13 bagels is going to depend on how that person working the register decides to ring them up. If they hit the one bagel key 13 times, I'm going to pay $16.25. If they hit a dozen bagels plus one bagel, I'm going to pay $11.25. So I could potentially pay two different prices for the same amount of bagels. That's not a function. Questions for me so far? Okay, so we're going to focus today on this idea of what is and is not a function. For example 1 on page 2, it says the relationship between the amount of time a car is parked in hours and the cost of parking in dollars can be described with a function. So they're telling us this is a function. Number 1, identify the independent and dependent variable in this function. We just did this with your test on Friday. What would be our independent variable here? Yeah, the time that my car is parked. Time car is parked. That's the thing that I am in control of, how long I'm going to park my car in this parking deck. So then what would be our dependent variable? The cost. Because we know that this is a function, we can sort of describe it with this particular sentence structure. We know that cost is a function of time that we're parked. So for this particular example, cost is a function of time. So let's say that it costs $3 per hour to park your car in this parking deck, and they capped the price at $12. So if you leave it there all day long, it's not going to cost you more than $12. Let's sketch a graph for this function. Let's start by labeling our axes. So we said the independent variable is time, and the dependent variable is cost. So I'm going to label time on the x-axis and cost on the y. And then I know our grid lines are pretty faint here, but I'm going to go by ones. 1, 2, 3, 4, 5. That darker grid line towards the middle should be 5, 6, 7, 8, 9, 10. And then same for cost. I know the grid lines are a little faint. And then for cost, we know we have a maximum cost of $12. So I'm actually just going to sort of sketch in 2 more grid lines here. So we'll be a little off our graph for that $12 maximum, but that's okay. So let's look at some points that are going to be on this graph. If I don't park in the parking garage, how much will it cost me? If I never pull my car in there? 0, yeah? How about if I park there for 1 hour? That's $3. If I park there for 2 hours, that's 6. If I park there for 3 hours, that's 9. If I park there for 4 hours, 4 hours was 12. How about if I park there for 5 hours? Also 12, right? That's the maximum that we'll pay. So if I park there for 6 hours, it's 12. For 7 hours, it's 12. For 8 hours, 9 hours, 10 hours, it's all going to be 12 from there on out. This is a function because for any particular number of hours, I can tell you with no uncertainty exactly how much you will need to pay. So if you're going to park there for 11 hours, I can tell you with 100% certainty that it's going to cost you $12. So there's a bunch of times that will cost you $12. The problem would be if you said, well, I'm going to park there for 4 hours. And I said, well, maybe it's $12. Maybe it's $8. I'm not sure. It depends on who the parking attendant is, right? That's no good. But since for any given amount of time, I can tell you how much it will cost to park there, this is a function. So let's pick a point. Let's say 3,9. What does that tell me in the context of this problem? Yeah, parking for 3 hours costs $9. You give me a time and I can tell you how much it's going to cost. That's a function. Questions for me on example 1? Okay, now turn the page and take a look at example 2. We have a menu here for a burger place. We've got prices and descriptions for some of their burgers. Based on the information that you see on this menu, I want you to tell me if burger price is a function or not. So we know the bagel thing was not a function. I want you to take a couple minutes, talk to the people around you, and try to decide if burger price is a function, right? Is the price of a burger based on the number of patties and the stuff that I've got on it? Or is there some other pricing system that they've come up with, like our bagel problem? So I want you to take a couple minutes and take a look at problem number 2. Okay, let's take a look at this. So the first thing I noticed is that we've got sort of different amounts of patties and cheese on each of these. That's how these burgers are different, right? We've got a regular cheeseburger, a double cheeseburger. This one is essentially a double hamburger. And then we've got like this quadruple burger going on. Did anybody try to figure out prices for components of burgers? You could find the price for cheese without too much difficulty here. So that's where let's start. Okay, if we want to know if it's a function of price of individual components, right, then we should try to find the price of some of those individual components. So the only difference between the just patties burger and the double cheeseburger is 2 slices of cheese. So if I take my double cheeseburger, which is $4.59, and I subtract the price of the just patties burger, which is $4.09, I get 50 cents. That should be the cost of 2 slices of cheese, yeah? That's the only difference between these 2 burgers. So this is the cost for 2 slices of cheese. So then, are we okay with saying that for 25 cents, that would be 1 slice of cheese? Does that seem reasonable? 25 cents for a slice of cheese. Okay. So I can know the cost of a slice of cheese. That should be the difference between these 2. The tricky part is that there are more differences between the rest of these burgers as I start to compare them. So wouldn't it be nice if I could know the cost of a hamburger patty, right? If I could figure that out, what's the cost of a hamburger patty? Then I could know if that's the only difference between these prices, that and the cheese in some cases, or if there's something else going on. So if I know the cost of a slice of cheese and I take it out of the price of a cheeseburger, does it seem reasonable that would give me the price of just a hamburger? Okay, so let's do that. Our cheeseburger is $3.49. If I subtract the 25 cents for the cheese, that would give me $3.24. That should be just a hamburger, right? A cheeseburger with no cheese. So I have a single hamburger here, theoretically. And then we also have some information about a double hamburger. Now, this wouldn't be just the cost of a single patty. Why not? What else? Yeah, when I order a cheeseburger, it's not just like patty cheese that they slap on a plate and throw in front of me, right? But if you ordered it that way, it could be. But generally, they come on a bun, and usually with at least a few toppings, maybe ketchup and mustard, maybe onions or pickle or lettuce or tomato, depending on where you are. But yeah, this price is not just a single patty, it's the other stuff that's a default for a burger, right? So how do I figure out the price of a patty? Yeah. So you use the sort of double hamburger here? Yeah, I'm going to do the same thing. I'm going to take the just patties because that's 2 patties, no cheese. Here I've got 1 patty, no cheese. So I'm going to take that just patties, which is $4.09, and I'm going to subtract my hamburger price. The only difference between this and this is a single hamburger patty. So if I subtract this, I get 85 cents. That should be the price for 1 patty. I say should be, and I'll put a question mark there, because I'm not 1,000% sure if they've adjusted their pricing in some way, like our bagel problem, then this price is going to be different. That price I could find would be different depending on the particular burgers that I look at. So let's double check these prices. So a double cheeseburger is $4.59. If price is a function of the stuff on the sandwich, then I should be able to pay the same price for a cheeseburger with 1 extra patty and 1 extra slice of cheese that I pay for a double cheeseburger. Does that make sense? I've got the same stuff making up my sandwich. If it's a function, that cost should be the same. So a cheeseburger, right? I'm checking the price of a double cheeseburger. A cheeseburger is $3.49, and it includes the bun and the toppings we talked about earlier. It also includes 1 patty and 1 slice of cheese. So let's add another patty, which I think costs 85 cents. And let's add another slice of cheese, which costs 25 cents. Will someone type that in their calculator and tell me what you get? $4.59. For my sort of self-created double cheeseburger, I would pay $4.59. The double cheeseburger on the menu, also $4.59. So for the same stuff, I would pay the same price. Let's double check the other one, that Big Island, that mega cheeseburger. So for my self-created Big Island, let's start with our cheeseburger again. But this time we're going to add 3 patties. So I get a total of 4. So 3 times 0.85. And 3 slices of cheese. So 3 times 0.25. What do we get here? $6.79. When you know it, that's the same price for that same burger I just created on their menu. So is this a function? Yes. Whatever I want on my sandwich is the same price if I cobble it together myself or if I order it from their menu, right? That means we've got a function. For the same sandwich, I'm paying the same price. So is this a function? Yes. The price is a function because you would pay the same amount for a, I'm going to abbreviate here, double cheeseburger or Big Island, or for a cheeseburger with extra patties and cheese. If the cost is the same, no matter how I put it together, that's a function. Unlike with our bagel example, where it mattered how I typed it in the register, I got different prices depending on how I chose to count to 13. Here, I get the same price no matter how I choose to assemble that burger. Questions for me on problem number 2? Okay, so we've talked a lot about, in context, how I determine if I have a function or not. The last thing I want to look at for today is how I determine if I have a function based on a visual representation, based on a graph or a scatter plot, okay? So I want you right next to problem 3 to write down vertical line test. That's essentially what we're using here. It's something called the vertical line test. So the idea that we looked at with our bagel problem and with our burger problem was that for the same amount of stuff, I should expect one price, one cost. If I got multiple costs for the same amount of stuff, that was a problem and that was not a function. So what I'm looking at with a graph is for one number that I pick for my independent variable, for one X value, I should only get one Y value, okay? So anywhere that I put a vertical line on my graph, I should only ever hit that graph in one place. If there is any spot on the graph where I can draw a vertical line and touch the graph more than one time, it is not a function. So if I take a look at the vertical line I've drawn here, I can see we hit our graph in 2 places. That means that this is not a function. I should only ever be able to touch my graph with a vertical line in 1 place. How about for our scatter plot here in the middle? Where do I have a problem? What x value? Yeah, at 3. If I put my vertical line at 3, I hit 2 different points. That makes this not a function. That's the only place where I have a problem, but I can't fail the vertical line test anywhere. So this is also not a function. And then for our last example here, we've got an input-output mapping. If you want, you can think of these as points, right? 1, 0, 2, 0, 3, 0, and 4, 0. So if I plot those points, I would have 1, 0, 2, 0, 3, 0, 4, 0. Would I fail the vertical line test with these? No, no vertical line would ever hit more than 2 points. So this one's okay. This one's a function. Now, I would have a problem if I did something like 1, 0, 1, 5, 1, 15, 1, 10, let's say. So to plot that, I would have a point here, and a point here, and a point here, and a point here. I have a vertical line that hits every single one of those. So this would not be a function. So that's what we see when we've got either a function mapping, a scatter plot, or a graph. Okay, we're looking at that vertical line test as a sort of quick and easy way to be able to determine, do we have a function or not? For homework tonight, you have a Delta Math assignment. You're going to see 2 different types of questions. So you'll see the assignment heading and then sort of 2 like little things underneath it. You have 5 total problems to do. They're going to ask you these types of questions. Okay, is this a function or not? Okay, your Delta Math assignment, again, it's 5 questions for homework tonight, should be done by the time I see you for class tomorrow.